Uh, Good afternoon, everybody. Welcome to the CSC webinar. I am Ari-Matti Sareen, and today we will be talking a bit about changes coming to the CSC system, especially our new Puhti supercomputer and Allas data storage system. To start with, I might mention that this webinar will be recorded, and the recording will be available in about a week or so. So if you want to return to it or wish to point it to one of your colleagues. Also, the slides I'm using today will be available at the webinar webpage. So what will be the changes coming? So there will be something familiar. So the Puhti supercomputer will be very similar system to Taito that we have now. It will have a large GPU partition, Puhti AI. Okay, similar to what we have in Taito now, but with much more capacity. And then next year we will have Mahti supercomputer, and something totally new will be the Allas object storage system, and I will be talking all of these in more detail in a while. One thing I might mention is that, as you may have noticed in the customer email we sent last week, the Puhti system is sadly a bit delayed. I tried to go through all my slides and change the dates to the current situation, but if there's some discrepancy in the slides, I apologize for the confusion. So the scientific drivers for new infrastructure, why do we need new computers? So we need machines for large-scale simulations, for things like climate change, space weather, fusion reactor simulation, things like that. Mid-scale simulations for material sciences. On many fields, data sets are growing, so we will have more and more data-intensive computing, especially in things like bioinformatics. That is my sort of own area of expertise, language research, computational econometrics, and others. Some of this data-intensive computing is using data that is sensitive data, and so the law makes some extra requirements on how that data should be managed. So that puts also some requirements for the system. And various artificial intelligence systems, machine learning systems like that are becoming more and more important for things like language research, computer vision, even for bioinformatics and other reasons. And finally, Internet of Things and various data streams for measuring instruments and so on are coming more and more important for researchers. So here's sort of general picture what our system will be. So the cloud and container things, so cPOTA cloud, ePOTA cloud for sensitive data, Rahti container count, these are all existing services and will continue as before. We will have 2 new computers, so the Puhti will be coming now soon and Mahti early next year. And sort of in the middle, connecting it all will be our Allas object storage service. So Allas, it's meant for storing your data during the duration of your computing project. So it's not something for long-term storage or permanent storage. It's meant to store your data while you're still working on it. Data can be accessed both stored and retrieved directly from anywhere in the internet. So not only CSC supercomputers, but your local workstation, various measurement devices, and so on. Sharing will be more easy than undercover systems. So if you choose to open data, you can get directly a URL for it, so you can share it for anybody on the internet. And as simple as it can be accessed with the web browser. So some technical details on the new systems. So Puhti-computing cluster will comprise of 3 partitions. So there will be the main CPU partition, almost 700 CPU nodes with total of over 26,000 cores, with theoretical maximum performance around 1.8 petaflops. There's the GPU partition, Puhti-AI, which will have 80 nodes with total of 300 and 200 CPU cores and 320 Volta 100 GPUs with theoretical peak performance of 2.7 petaflops. In addition, there will be Puhti-FMI, and this is partition owned by FMI, so Finnish Meteorological Institute, and it's reserved for their use, so it's not available for general CSC users. All in all, the system will have 4 petabytes of work disk for active use. All the nodes will be equipped with the latest generation Intel processor. So this processor architecture was released this April, so they are really the latest generation. Each node will have 2 CPUs, each with 20 cores, so 40 cores per node. They will support the AVX512 instruction set, which can mean, at least in theory, 2 times speed up compared to the Haswell CPUs in Sisu and Taito. Now, this of course requires that the code supports these instruction sets and that the code is compiled to take use of them. But and the AE nodes will have support for VNNI instructions, which can lead to considerable speed up in AE inference workloads. Also, all the nodes will be connected with fast InfiniBand HDR interconnects, and this is also the latest generation of InfiniBand interconnects, and Puhti will be the first machine in the world to have these, so we are at the very cutting edge also there, and I have to say, being on the cutting edge is one of the reasons why we are a little bit late in the acceptance testing. So the Puhti-AI is an 80 nodes with 320 GPUs in all. These are the latest NVIDIA Volta V100 GPUs. Very fast network for each link, and each nodes will also have 3.2 terabytes of fast SSD disk. So it will speed up I/O heavy workloads considerably. The most common machine learning frameworks will be installed by default, so things like TensorFlow, Keras, PyTorch, so on. The cloud environments, both Puhti and Rahti, also have some GPU capacity based on older generation Pascal GPUs. So basically, stuff we now have in the Taito GPU at the moment. To look at the technical specification of the nodes. So most of the nodes will have, so all of the nodes will have 40 cores, as mentioned previously. Most of them will have 192 gigabyte memory. There will be some nodes with 384 gigabytes of memory. Some fast I/O nodes with 384 gigabytes of memory plus 3.2 terabytes of fast SSD storage. We'll have 12 nodes with 768 gigabytes of memory and 6 with 1.5 terabytes of memory. So there will be many more large memory nodes available than now. So hopefully the queues for jobs that require larger memory will move a bit faster than now. And finally, for the Puhti AI partition, the same CPUs, 384 memories, 128 gigabytes in the GPUs, and those nodes also, as mentioned, have the fast local storage. The Allas storage, it's an object storage-based system with 12 petabytes of total storage space. And as mentioned, it is meant for storing the data during your computing project. It's not for long-term storage. And storage space is per CSC computing project. So it's not per user like we have now in, for example, HPC archive. The difference between an object storage and sort of more traditional file system-based storage is that object can be any blob of data. Typically, they are files. They can be stored in what is called a bucket, which can be considered a bit like a folder. But the system is flat. That means that there can be no buckets inside buckets. So no subfolders like you might be used to in file system-based systems. So, and each object can have a URL and can be accessed directly over web. Of course, provided that you give it access rights to everybody. Objects can also have metadata attached to them. Objects are technically replicated. Basically, every object or file there is stored in 3 copies. That means that if a machine breaks or disk breaks or whatever, it will not cause data loss. There is, however, no backup. That means if you delete a file, it is deleted and it cannot be recovered. And you cannot go back to say what was the situation last Monday or anything like that. So they are replicated against technical issues, but there's no backup, so you have to take care of that yourself. Also, notice that the object storage is not mounted as a disk system, so data cannot be accessed directly with the standard Unix file management commands. You need to use special tools. Initially, S3 and Swift interfaces will be so in this aspect, Allas is close to what we now have in HPC archive. Of course, the main difference is that HPC archive is tape-based and slow, and Allas storage will be much faster. There will be variety of data management features built on top of Allas. For example, a variety of web client kind of thing that makes it easier to manage your data and share what you want and not share what you don't want. But it's likely that not all of these features will be available when Allas is first launched. So some of them will be introduced later. Later on, there will also be Mahti supercomputer based on AMD CPUs, about 200 cores in total, and 8 petabytes of hard disk. But as mentioned, this is something that we will have next year, so there will be more information when it's more closer to being launched. So some words on the schedule. We already sort of started earlier this year by decommissioning the older part of Taito, the old Sandy Bridge nodes. Right now, Puhti and Allas installation and acceptance testing is going on. Current timeline is that Puhti and Allas will be available for customers in this August. Exact date will be communicated later. In mid-August, SISU will be decommissioned. Then Mahti installation will start late this year, and hopefully it will be operational early 2020. Taito will be available until the end of this year. And as mentioned, Mahti will be available till next year. It's very regrettable that we have to do this in sort of piecemeal. It would be much nicer if we could first install the new machine and then decommission the old ones when the new one is available. Sadly, this was not possible because we simply don't have the room in our data center in Kajaani. So we had to decommission and dismantle the old part of Taito to have enough room to install Puhti and Allas. And we will need to decommission SISU to make room for Mahti installation. Mahti will also need some extensive work on the data center itself because it will be water-cooled system, unlike SISU, which is air-cooled system. So what will change in the new infrastructure? Well, first of all users need to apply for the new services. So even if you already have access to Taito or SISU or both, you will need to apply for access to Puhti and Allas. You will need to transfer your data from your current home and work and project directories to the new infrastructure. So typically this would mean that you will first migrate it to Allas and then to supercomputers when needed. And detailed instructions for this will be provided once we have Allas up and running. The current data in Taito and SISU remains available until the end of 2019, but we hope that you will start moving your data early on, especially if you have much of it. So if everybody tries to move their data on the last week, it's quite likely that there will be some congestion and problem. So it's recommended that you start moving as soon as we get the instructions ready. In the new system, most of the storage is provided per project. Currently is provided per user. So this is a clear change. So in Allas, typically the data is available for the lifetime of a project, so typically 3 to 5 years. If you have need for more long-term storage, then there are other services like CSC fair data, university services, and so on. Default quota in Allas will be 1 terabyte, but project manager can apply for more quota. One change will be that used storage space consumes building units. So that's a need. And again, there are no backups, so if you should take care of that yourself. In the future, Puhti and Mahti will have separate file systems. So currently, Taito and Sisu share a file system. So, for example, the home directory for both Taito and Sisu is the same. This is a bit of thing where you have to balance the good and the bad. So of course it's nice and easy when you share the file system between all machines, but then that also means that you have a single point of failure. So in the past we have had situation when the file system has had problems, and that means both Taito and Sisu have been unavailable. So in the future we hope that separating these, we will have a bit more robust system, and hopefully at least one of the machines will be available even if we have problems with the other one. In the future, home directory will be user specific as it is now. It is quite small, so default quota is just 10 GB, so it's just meant for your personal setup scripts and batch scripts you want to save and things like that. There is an Apple folder, which is a project-specific directory, and that is meant basically for software installations done by the project or project member. The default quota there is 50 gigabytes, and there will be Scratch, which is similar to what we now have called WorkDir. Again, that will be project-specific, not user-specific as it is now. The default quota is 500 gigabytes, but that can be increased easily by the project manager. Again, as with Allas, user storage space consumes building units. Also, automatic cleaning will be operational from the start, and there will be no do not remove folder like we have now. So all of the storage in Scratch will be temporal and will be gone in 90 days. So you should store your stuff to Allas after you are done working with them. And okay, there will be no backups in any of the storage areas. So as for running programs, if you are running pre-installed applications, it will be very similar to what you are doing now. So there will be a module system, pretty much like we have now. It's probable that for some software, at least the optimum parameters, number of CPUs, and so on, will change in the new system because the nodes are different. But we will try to update all the software-specific instruction pages to reflect the new system as soon as possible. The patch system will be Slurm like it is now, so the patch shop scripts will be very similar that they are now, but it's possible that some queue names will change and some default running times and so on will change. So it is recommended that to write new patch shop scripts starting from the templates in the CSC user guides, and these will be updated as soon as possible. If you are installing applications by yourself, there will be GNU and Intel compilers available. Various high-performance libraries will be pre-installed, and at least in the beginning, the MPI library will be full MPI provided by the machine or a company that provides the machine. So it's based on OpenMPI, but with some small changes. If the application that you have compiled yourself, you should probably compile them again to make sure that they use all the features in the new processors to make them as fast as possible. It's possible that the configure scripts and make files may need some modification, but it should not be anything major. And as mentioned, we provide this project-specific Apple disk area for them. So if you install something, it will be directly usable for all the members of that project. So that is something that is useful and easier than what it is now. Also, we have mentioning here, we will be providing instructions how to use Conda to maintain your own software environment. So that is relevant to some application areas, but not necessary for all. Also, we will have support for singularity containers. So that is one way of installing your software. So you can run singularity containers, and you will also be able to run most Docker containers either as such or with small changes. So if you are developing applications yourself, we will have some new performance analysis and debugging tools available. More information on those will be provided later. And the Puhti is very similar system to Taito, so probably no major code changes necessary. But efficient use of Mahti may require some further optimization for example, hybrid OpenMP, MPI workloads. And again, the Apple disk area is provided for own software installations. We will organize several workshops and webinars about the new infrastructure in this year and all the way to 2021, both with very basic level and a more advanced level for people who are already familiar with current systems and just want to get the fast track to using the new systems. And all online information is in the process of being updated, and should be available when the new machines are available. And more information on these will be on our web pages as soon as the dates are clear and so on. So I already mentioned something about the timeline, but Taito will remain in use all of this year. Sisu will remain in use until mid-August. Puhti and Allas should be in general production and in use sometime in August. As I said, the exact date will be communicated later. Mahti installation will start this year and hopefully it will be in production early next year, but more about that when it's the date is closer and we know in more detail. I think already went through this, so I think the most important date is that Sisu will be decommissioned in mid-August, and that the data will still be accessible via Taito, and Taito will be available all this year, so you have time to move your migrate your data to the new systems. So best way to check the up-to-date information about timetables and changes and so on will be on our web pages, so research.csc.fi/DL2021 utilization. I will be happy to answer any questions you might have. And as I mentioned in the beginning, this webinar was recorded and recording will be available in around a week. The slides are available on the webinar web page, and we would very much appreciate your feedback. It will always help us to develop these webinars further.